whoops, that's going to go down till there. It's going to be at its lowest point there. It's then going to increase all the way up till there. Then it's going to start dropping, and it's going to stop at 180 degrees. And the same over here at negative 180. So that's the standard sine of x graph, which has just been shifted to the right 45 degrees. That point is 45 degrees. And that point over there is negative 135 degrees. We can calculate this intercept if we want to. In fact, I think we're going to do that. That's when x is equal to 0. So that's not sine of 0 any longer. That's going to be sine of 0 minus 45 degrees, which is going to give us negative root 2 over 2. And that's that intercept over there. And that's the graph f of x. The next graph, g of x, is going to look at the standard cos graph, except it's 3 times as big, or rather 3 times compressed. So it's cos of 3 of x. When x is equal to 0, cos of 0 is 1, so that point is fine. When x is equal to 30 degrees, 30 times 3 is 90, cos of 90 is 0. When x is equal to 60 degrees, it's going to be cos of 180, which is negative 1. And then 0 again, and then all the way up to 1, and then 0, and then negative 1 over there. And the same thing in the negative quadrant, 0, negative 1, 0, positive 1, 0, negative 1. That means that our graph is going to look a lot like this. And that's the graph g of x. It's the standard cos graph, but it's 3 times 3 sort of waves instead of just one wave. In the next question, I ask you what are the points, or what are the x values where the two graphs intersect, or rather when f of x is equal to g of x. Notice that there's 1, 2, 3, 4, 5, 6 different points. We are now going to find those different x values. To find those x values, we're going to say it's when f of x is equal to g of x. That means that sine of x minus 45 degrees is equal to cos of 3x. Problem: sine and cos are different functions. I'm going to make the sine x minus 45 degrees is equal to sine of 90 degrees minus 3x. Now I can drop my signs. X minus 45 degrees is equal to 90 degrees minus 3x plus k times 360, and this is for quadrant 1. Or I could say that sine of, oh sorry, not sine, x minus 45 degrees is equal to 180 degrees minus 90 minus 3x plus k times 360. Both of these are when k is an element of integers. And this is for quadrant 2. Remember that sine is positive in quadrant 1 and quadrant 2. Because we're using general solution, we've got to use quadrant 1 solution and quadrant 2 solution. The quadrant 1 solution is going to read x minus 45 degrees is equal to 90 minus 3x. Take the minus 3x across, it becomes 3x plus x, which is 4x, is equal to 90 degrees plus 45 degrees, which is equal to 135 degrees, plus k times 360, which means that x is equal to 135 degrees divided by 4. 136 degrees divided by 4 is going to give us, that means that x is going to equal 33.75 degrees, which is 135 divided by 4, plus k times 90 degrees. That's our one possible solution. Our other possible solution is going to be x minus 45 degrees is equal to that. 180 minus 90 is going to give me 90 degrees. Take the 45 across, so that becomes plus 45 degrees. Minus times a minus 3x becomes positive 3x. Taken across becomes negative 3x. X minus 3x is going to give me minus 2x is equal to 90 plus 45 degrees plus k times 360 degrees. 90 plus 45 is equal to 135 degrees. That means that x is equal to negative 135 degrees divided by 2, which is equal to negative 67.5 degrees plus k times 360. All of this happens when k is an element of integers. That means that these are our two possible solutions. Taking that onto our graph, which we have over here, the two possible solutions we have are either x is equal to 33.75 degrees plus k times 360, or x is equal to negative 67.5 degrees, also not plus k times 360, plus k times 90 degrees. And our other solution is negative 67.5 degrees plus k times 180 degrees. Now there's one mistake I made in the previous example. When I divided through by this negative 2, the 360 has to also be divided by the negative 2, which will make it 180 degrees. So it's plus k times 180 degrees. The reason it does not have to turn into a negative k times 180 is because, remember, k is an element of integers. Because k is an element of integers, k can be positive or negative in any case. So we don't have to change that to minus k times 180. Now let's look at our possible solutions. The first one being when k is equal to 0. That's going to be 33.75 degrees plus 0, which is just 33.75 degrees. When k is equal to 0 here, x is going to equal negative 67.5 degrees. Now that's negative 30, negative 60. That means that this point over here is negative 67.5 degrees.